last time. More. Context switching is something like scheduling. It is one of the algorithm for scheduling. Then it forms it tries to relate this switching from one process to next process through the software or through the by usage of function, C programming softwares. Okay, unlike other one, unlike that simple scheduling and round robin fashion. Okay, so let's continue with this preemptive scheduling. This is another form of scheduling. We'll know in a while. Why we are dealing with preemptive scheduling is to reduce the limitations in cooperative and cyclic scheduling of task. Okay, there will be some of the limitations in this scheduling of task, especially when it is in cycle. Okay, one after another, and it has to return back the row T1, T2, T3. Then it comes back to T1, the row T1, T2, T3. Then again T1, T2, T3, hyper period. So in this kind of cyclic process or a cooperative scheduling, this is also called as cooperative scheduling, we have some of the limitations. Okay, we have some of the limitations, like for example, some of the time slots are not occupied. Okay, or sometimes the guard bands between these small time slots may cause overheads. Okay, in long run, in long haul communication, these overheads are one of the problem. Okay, so there are some limitations here. So how to deal with these limitations? Okay, but let's see first what are these cooperative schedulers and cooperative scheduling. It schedule each ready task cooperates to let the running one finish. Okay, so that means if one task is running and another task comes, then that task has to wait until the initial task completes. Okay, it's completed. So this is called as cooperative schedulers. Cooperative scheduling, a long execution time of a low priority task, lets a high priority task waits at least until that finishes. Okay, sometimes this line, this first, second, third line is very conceptual. Sometimes what happens is, till now we have studied that, okay, till now what we have studied that we need to give priority to the higher priority task. Okay, higher priority task finishes, then only the low priority task will get the chance. But in cooperative scheduling, what happens is sometimes low priority task has to finish first. In that case, high priority task might have to wait until the low priority task finishes its task. Okay. Now, cyclic scheduling. What is this cyclic scheduling? During this cooperative scheduling, okay, during this cooperative scheduling, the one which I have just mentioned is cyclic but without predefined time slice. Okay, that means you remember what is this time slice? Time slice, we studied that time slice are time slots in which each of the process will be occupied. Okay, but here there is no predefined time slice. Assume that an interrupt for service, okay, Assume that an interrupt for service from first task occurs just at the beginning of the second task. Okay, the first task service waits till all other remaining listed or queued task finishes. Okay, worst case latency equals the sum of execution times of all tasks. Now, okay, so cooperative scheduling might is somewhat like higher priority task giving chance to low priority task, which was not happening till now. Now, in cyclic scheduling, this cooperative scheduling is in a cycle. It will come on repeating. It will be repeating, but there is no time slots. There is no mechanism of time slicing. And we have seen very detailing what is this time slice in last class, dividing the time frame into time slots, right? That is time slice. Now, the first task has to wait, okay, until the next task has to resume, or the queued task or a listed task. Those are the one who are waiting is listed or queued task until those task gets its chance, and this process will repeat again and again and again. That's why it is in a cyclic process. But what is the disadvantage is that it will have a very low latency. Okay, low worst case latency equals the sum of execution times of all tasks. That means in this kind of scenario, in this case, there is no proper time slot for one. So when there is no proper time slot, sometimes the task might require very long time. That will lead to low latency. Am I clear to you all? That is one of the drawback of this system, of this algorithm, preemptive scheduling. Okay, getting? This is one of the drawback. But what is the advantage here? Higher priority task giving chance to low priority. That is one. Okay, it is not time bound. This is one of the drawback. Okay, this is not time bound. This is in a cyclic process. Yes, of course, this should be in a cyclic process, all this task scheduling and all. So to achieve efficient CPU or multitasking, RTOs uses an orderly transfer of control from one code entity to another. See, of course, we all are studying this to achieve efficient CPU utilization. These are all different algorithms, okay, to deal with your scheduling. So these are all theory which I have just explained for you. If you want to go through a real-time system that does not perform a required operation at a correct time has failed. All these are explains preemptive scheduling, which we have just discussed right now. Must monitor system and the execution state of each code entity, and it must ensure that entity receives control of the CPU in a timely manner. See, always remember that when a process takes over that CPU, or when CPU gives the chance to the process, the resources of that process needs to be present. First, the resources should be ready in the CPU, in the OS. Okay, a real-time system that does not perform a required operation at the correct time has failed. Sometimes what happens is the task is not performed at correct time. Okay, what it will cause is it will cause some that range from beginning to catastrophic. Some failures will be there, system failures. Response time for a request for kernel service and the execution of time of this must be fast, and this must be response time of the kernel should be as fast as possible, and it will go on. See, all theory only. You can have a study, okay, by yourself, Anna. It's all the things which I have studied just a while ago, Anna. Preemptive scheduling. I hope you got what is the difference between preemptive scheduling, context switching, simple scheduling, and what is that, round robin. See here, a program code that is input output bound or compute bound cannot be allowed to monopolize a system resource if a more important task requires the same resource. These are some of the protocols in order to achieve this preemptive scheduling. Okay, some of the rules, we call these as protocols, or uh, some of the small factors which must be taken in the algorithm. Okay. Now, there are these 4 states in preemptive scheduling, which is also very simple, like last time: running, ready, inactive, blocked. Okay, inactive might be a different new one, but running, ready, blocked we have seen already, right? So running, we know this, when task takes the control. Okay, ready, the task is not blocked and is ready to receive control, and also in ready you have all the resources. Okay, is ready to receive control. When the scheduling policy indicates it is the highest priority task in the system that is not blocked. See, in scheduling policy, when the particular task has gained the highest priority, that is ready, it is becoming ready. Inactive, what is inactive? The task is blocked. Okay, the task is blocked due to some it could not finish on time, it had some failure, so that's why it got blocked. Requires initialization in order to become ready. See, in inactive, it is the task is blocked, but it requires some initialization in order to become ready. But blocked, please see these two. Okay, inactive and blocked is quite similar, confusing. The task is waiting for something to happen or for a resource to become available. See, okay, which one is more prior, inactive or blocked? Which has more chance to happen? Inactive, right? Inactive has a more chance. Remember, the task is blocked, so requires initialization. But in blocked, something needs to happen here. Resources needs to be available. But inactive, the resources are available, but just we need some initialization. That is one major difference, okay, of inactive and blocked. See, this is preemptive scheduling. Okay, the block diagram of preemptive scheduling. So in preemptive scheduling, yeah, why it is a cyclic process? See, the highest priority task ready to run is always given control of the CPU. I have written in very simple lines actually. See, low priority task was running here. Okay, on a low priority task was running. Now suddenly a high priority task interrupts. Okay, when it interrupts, it will go to the low priority task, will go to will ask the CPU. CPU checks its ISR, that is interrupt service routine, and in the interrupt service routine, if the interrupt is happening from a higher priority task or even lower than this, say check them. Okay, it will check in inter service routine. So in ISR makes the high priority task ready. So okay, this will make the higher priority task ready. So it will jump to higher priority task, and during that time, the low priority task is in a idle mode. It is not running. The CPU, the low priority task is not running. Okay. If an ISR makes a higher priority task ready, the higher priority task is resumed. See, that is your interrupted task. And the interrupted task, the higher priority task. Whenever there is an interrupt, there will be ISR, right? There will be usage. The CPU will use ISR to get the information of the priority of the interrupts, which we have studied already. Okay. So, and after this, it will come back to the low priority task. See, as the time goes on. So, see, it always jumps from low priority task to low high priority task. So, a preemptive scheduling is somewhat like, okay, it is scheduling a process, a task between high priority and low priority also. Okay, so most commercial real-time kernels are preemptive. Most of our system, computer, laptop, mobile, anything, okay, that is programmed is your most of the time preemptive scheduling. So it is one of the important topic here. So advantage of preemptive scheduler, what is the advantage? Execution of higher priority task is deterministic. What do you understand by deterministic? Deterministic here I mean it uses ISR to determine. Okay, CPU executes, CPU analyzes it might do some calculation, and it comes to the conclusion whether that is higher priority task or not. Deterministic. That's why this is deterministic. Task level response time is minimized. Task level response time is minimized. Okay. Disadvantage of preemptive scheduler. What is the disadvantage? Should not use non-reentrant functions unless exclusive access to these functions is ensured. Now, sometimes this higher priority task might come, okay, might interrupt, but that might be some virus or some re-repeating functions which has already entered the main program. Now again he wants to enter. Sometimes we need to check this kind of functions. This is not good. Okay, it might create confusion or might create your scheduling process here. So this is the explanation of your preemptive scheduling. Please go through. Okay, whatever we have studied, okay, is already here, but more you need to explain this diagram in more of this context: running, ready, inactive, blocked, which is explained here. See, that is ready. First it is ready to run, gets control of the processor, task runs, this is in ready state. Okay, the higher priority task, that time when this is a low priority task is running, that time higher priority task is in ready state. Before a task can run, it must load its context from its memory stack. See, if a task is preempted, it must load its current state. This context is restored when the task is given control of the processor. And that time, see, when low priority task comes to, when the CPU gives chance to high priority task, that time a low priority task will be in the state of inactive. That time it will be inactive. But the block gi load the Muhammad a task runs until it yields this will be active. Now higher priority task will be running. That time low priority task will be inactive. Higher priority task finishes. Now when it finishes, it will jump back to low priority task. Now low priority task will be running. That time higher priority task will be blocked because higher priority task has finished its task. Okay, this is preemptive scheduling. Is it clear or not? Any doubt? This is scheduling is finished. This